Well, we've got another quiet evening here. Just got the tropical moistures flowing northward here in our part of Texas. Very little convection here. Most of that's heading up to the Central Plains this afternoon. Let me get my charts ready here. Got a little bit of a late start. Waiting for everything to render, but I think we're on track here. So let's check out what's happening outside right now. And there we go. Got a little bit of a stratocumulus, altocumulus layer, something up there. I think we've got a lot of spreading of some cumulus under an inversion, or that could be a little bit of debris from some shallow convection that went up earlier. Believe it or not, I just woke up about 2 hours ago. I've been on a late schedule getting programming done, and I'm kind of starting out looking at the forecast from scratch, the way a forecaster might do when they're coming on shift. And so you get to see it kind of put together here. So let's see here, weather charts. There we go. All right, let me take a look at the chat and see what we got going on here. Sue M is here, and Andrew, Ryan, and Eddie W. Fun with Tech is on. Mike Estwick. Ryan is in the office finalizing everything and enjoying a little downtime. Kevin McKinney also joining us. Ron Chalfant out in Southern California there. Looking forward to another informative broadcast. Robert Terrell says he was whining on Facebook because it got up to 113 there in Lubbock. Then his friend in Phoenix said it was 120 there. Burl H. got his forecasting and analysis handbook today. That's great to hear. Of course, that book is on the weathergraphics.com site, and that's got just about all of the expert knowledge that I have. Let me see if I can bring that up. Yeah, there's that book, Weather Analysis and Forecasting book. That's at weathergraphics.com, so there's your 15-second commercial there, so pick up a copy if you can. 108 degrees there in Scottsdale, Arizona. Lloyd McCarter says, good evening. High humidity there, 100-degree heat advisory. Scattered storms predicted there for tomorrow and Monday. Ryan says things are finally dry there in southern Florida. Mick is checking in. And Charles Skelly also, and EAS Fan 51. Robert Terrell saying he wants that forecast book. Well, last time I checked the cabinet, I think we had about 5 or 10 in stock, so anything would certainly ship on Monday. Okay, here's the forecast, or here's the analysis that we have. This is from SPC, and you notice that we have high pressure out to the southeast right here. This is part of the Bermuda High that we normally see this time of year. And out to the west, low pressure in the Lubbock area, so a bit of a heat low. Certainly I don't think there's anything baroclinic going on in that area as far as temperature contrast, so a lot of this is probably due to the very intense heating there on the Llano Estacado. And up to the north, we do have a cold front moving southward, and that's driven by this ridge up in Wyoming and Nebraska. So there's the leading edge of our cold front from the Quad Cities through Topeka, Kansas City, down to Dodge City, and out towards Trinidad. So it looks like that's on its way south. 20-knot wind. Yeah, that's going to bring it at least another few hundred miles to the south there. Got a bit of an enhanced risk starting from about East Kansas all the way up to the Chicago area. Slight risk around that all the way back to about Garden City. Not Garden City, Liberal, Kansas. So this pretty much follows the leading edge of that cold front there. And most likely what we have going on here, just looking at this chart by itself, I would surmise that the 850 millibar flow is kind of feeding this area like that. So probably some good storm relative inflow vectors. 250 millibar chart showing fairly zonal flow. Got one little trough coming across the northern Rockies right there. There's the axis of the polar front jet. And this time of year we always check down to the south for the subtropical jet. We're up at 250 millibars. Do we see that? Well, maybe 40 knots there at Monterey. Do see a low pressure area around the Phoenix area. Wonder what could be causing that. I would first look for any convection in that area to see if that's maybe a mesoscale convective system of some kind or remnants of a tropical storm. And if not, I would certainly consider that to be some sort of dynamic feature. And also looks like a low off the coast of Louisiana out there in the Gulf. So in between, northerly flow here in Texas. If we go up to 200 millibars, now we can pick up that subtropical jet, but it is out of range of the radiosonde network. You can see only one little radiosonde there in Monterey, and I don't know why we're so short on soundings in this part of Mexico. I wonder if it's that Civil War problem that they got going on down there, disrupting things or disrupting the budget. But the model indications of the subtropical jet looks like that is just south of the border. So that could always enter the picture later. And we can see a little bit of that low pressure right there over the Arizona New Mexico border. And then the low pressure area further east, south of Louisiana right there. So you can see that if you go just by the height contours, you would probably place that right there in the center. But looking at the wind flow, you've got to place that a little bit further south out there and kind of refine the analysis. So sometimes these automated contours are not always dead on. And we can see 120 knots coming on shore there near Vancouver and Comox, north part of Vancouver Island, and bringing 125 into Spokane and out into Wyoming, 100 knots. So pretty good flow coming in from the northwest. And normally, when you have this kind of very strong flow descending the back of a ridge, that's going to tend to dig the trough even further to the southeast. So I think we're going to be looking at some height falls, pretty good height falls there in the Great Plains over the next couple days. 500 millibar flow showing the polar front jet pretty much up there in the northern plains. Little 50 knot flow there in Topeka and Springfield. 700 millibars, and this is where we look at the capping. 14 degrees Celsius at Fort Worth, so we're pretty well capped, and 19 and 18. That is almost 70 degrees up there, up at 10,000 feet. Pretty impressive there. And that's probably keeping things shut down pretty well there. 850 millibar flow. This is where we start picking up the low-level flow. This is up at 5,000 feet. See maybe a very weak, very well ill-defined low-level jet in this area right here. And looks like the better, deeper moisture is off to the east out in this area. So that's probably the reason we have the enhanced risk so far east. The ingredients mostly well east of I-35. And then down to 925. Yeah, now we do start picking up a little bit of the tropical flow here. And that's mostly heading up to the Missouri, eastern Kansas area. And that would be feeding the western part of that enhanced risk area. Okay, we'll probably skip the potential temperature analysis and go straight to the satellite. And there's our storms over Kansas. And I thought I had an animation going. I guess I don't. We'll see if we can get that started. So we've got a little bit of an MCS across most of Kansas there. The best looking storm looks right there near Dodge City. Pretty good anvil right there. And elsewhere, the tops on these storms, there's a few of them out there near Topeka that look pretty good. And then further to the south, this looks like a bunch of cirrus. At first glance, I was thinking maybe that was haze or something, but I think that is just old debris. But you can see what looks like a little bit of a anticyclonic circulation here in the cloud field here. That's centered over southern Oklahoma. Let me see if that's showing. Yeah, I think it actually is. You see how the streamline analysis of 200 millibars kind of wrapped up a anticyclonic vortex there. I think, see, this is from this morning. It looks like that has shifted down into Oklahoma itself, and now we're seeing maybe a little bit of a weak cutoff high over the state right there. So usually underneath those ridges we have some very strong capping, and let me see if I can bring up the soundings. I'll bring up Norman here, and we see a pretty strong subsidence inversion in place there. So this would be kind of underneath that upper level ridge. Fairly steep lapse rates from 800 to 500. But quite a bit of dry air aloft. And then we go up to Springfield and get a little bit closer to that MCS. Moisture is a bit on the weak side, so that's causing problems for that MCS. So you can see once we mix out the lower levels of the atmosphere, we're pretty much looking at dew points in the mid-50s. So if we take 90 degrees and lift that, we have a pretty high LCL and very little CAPE. So there's one indicator of problems for this line of storms. Let's go to Topeka. Okay, they've got some moisture there, about 16 grams per kilogram right there. Let's try to lift that with maybe 90. And we see a pretty strong capping there. Now at Topeka, we've got some very good CAPE there, and that's due to that presence of strong moisture there. Mixed dew points, those are going to be close to the upper 60s. And then further up the line towards Davenport, about 13-14 grams per kilogram of mixed moisture, which corresponds to low to mid-60s dew points. We'll throw in maybe 88 degrees, lift that up, and we see a little bit of capping and very weak CAPE there. So it looks like our better instability is down to the south, but only if that deep, rich moisture is coming in a phase with that cold front. And there's a quick look at the dynamics. See a pretty good trough coming through Nebraska and South Dakota. We know that the cold front is from about Chicago down to, let's see, I think I had that through, yeah, I had it through the Quad Cities, down to Liberal. There's the upper level trough there. So it doesn't look like a whole lot of support for the environment ahead of that cold front there. So we're kind of depending on where the better low-level moisture is heading north and intersecting that front. And let's see if we can bring up a little radar data on that MCS up to the north. Let's see, maybe Topeka will bring us into that area. We got the data loading for that. And let me see what we got on the chat there. 108 degrees there in Scottsdale. 100-degree heat advisory for Lloyd McCarter there. Storms on the way in Denver. Nice in Vermont. I think I may have read a few of these already, sorry. Audio very good tonight. 92 degrees at Canyon Lake, where Ancient Astronaut is. And now 98. Storms are already coming together, southwest of Cuba and east of the Yucatan from Ryan there. And SPC, Arizona, 2498. Hi, Tim. Hello. There's the Topeka radar. Looks like a very disorganized MCS moving through that area. Those storms near Dodge City look pretty good. I'm going to bring up that radar. But let's take a quick cross-section through one of these cells here. And we see, yeah, a little bit of overhang here, but the higher intensities are near the center of these cores. They've got a very distinct multicellular look to them. And there's the animation right there. So not particularly impressive reflectivity gradients in these. I'm not really confident these are going to do very much, and I would bet that there's probably some outflow well out ahead of these cells. In fact, yeah, this could be the outflow boundary. We are sampling this up at about 2,000 feet. Okay, there's the marker. So in this case, spectrum width is definitely showing the outflow boundary very well. And I guess we're looking at it doing something like that right there. So there's the outflow boundary. Wish I could transpose this to the reflectivity somehow. But in any case, I think these storms are probably getting a little bit of, the inflow is probably not that great going into these storms. Let's go to Dodge City and see how they look. Because they've got a couple of isolated cells in that region. And I would bet with it being Saturday, there's probably some chasers on those storms. While we're at it, we'll take a look at the tropics here real quick. The tropics are active. And we can see that we've got one disturbance coming in the long term here. 60% chance of formation heading towards Trinidad and northern Venezuela. And then this other one here, 80% chance of cyclone formation. Looks like that is going to be tracking up to the U.S. coast. The models earlier had been looking at maybe bringing that into Mexico. But they've backed off on this, and now this looks like it is going to affect the U.S. And here's the model forecasts for that disturbance just off the coast of Belize right there. So we're looking at maybe some sort of track over the Yucatan, around Cozumel, Cancun, or maybe further west towards, I don't know, what's that city in here? Merida. Let me see which models are going for these here. HWRF. Hurricane Weather Research Model, HWRF. So sometimes it's good to use the process of elimination and just see which ones are doing these outliers. There's the Clipper, that's a statistical model. Clipper again. Okay, so I think the better models, yeah, they're on this eastward track right here. So it looks pretty reasonable that we're looking at a track anywhere from Louisiana out to Mississippi, Alabama, and possibly as far east as Florida. But of course, the main I guess the main meaning of these tracks is heading it up towards the New Orleans area. TABD, I don't recognize what these models are. TABS. I don't think those are dynamical models or D-ship. I think those may be statistical. So, yeah, I think we're probably looking for maybe landfall, Louisiana, out Mississippi, Alabama, just based on that right there. Oh, yeah, let's see when that's going to happen. Let me just pick out a time and date. 108 hours, 22nd. Okay, 22nd. What's the calendar date on that? That's going to be Thursday next week. Okay, we'll see what happens with that. My other question is, what is the intensity going to be? I don't think I have enough data. Well, this one's going for 37 knots, 1002, 29. Looks like, if anything, it would just be a tropical storm or a low Cat 1. So definitely not Katrina here, so looks good. Okay, there's our storms out in the Dodge City area, laying down some pretty good outflow boundaries. You can see one very clearly right there, another one south of Dodge City like that. Spectrum width not showing those boundaries as well as on reflectivity. But yeah, you can really see them on velocity right there. So these are definitely some outflow storms, and you can see the separation between the updraft and these boundaries are on the order of about 10 miles. So they're laying down some pretty good cold pools and maybe some good structure, but these are not going to be tornadic storms. And looks like further to the north, this may be the cold front on its way southward. Looks like some higher level showers drifting over this area. Okay. So that's what's going on up there in Kansas. And I was going to talk a little bit about MCSs, and I've got a few slides up here for that. And maybe before we look at that, I'll show you a very classic MCS. We'll go to, let's see here. Yeah, this was a very well-known derecho, June 29th, 2012. I've got a couple of radar images from the Wilmington radar, so we'll pull that up. So this is not live data. This is from 2012. And this is showing a damaging MCS, a derecho. So that right there, you're looking at 1 hour of data. And one way we can get an idea of how intense it is by measuring the motion. Well, this is an hour of data. We can set a marker right there, bring it up to the very end. So we're seeing a propagation forward of about 50 nautical miles per hour. That's about a 60 mile an hour, 55, 60 mile an hour movement to the southeast there. So that coupled with the downburst winds is definitely going to mean trouble there. And one of the features that we look for like locally damaging winds are the rear inflow notches, and that would be like what you see right here. And that's where portions of the rear inflow jet are coming downward towards the ground, and that could locally accelerate pieces of these storms. I don't know if that's showing up on velocity or not. Well, we're kind of perpendicular to the radar site. That's not good. We're looking at it this way. So yeah, we're not getting the best look at this storm, but anyway, that's what a rear inflow notch would look like right there, and probably another one up here near Columbus. And let's take a quick look at a cross-section of that cell. So you can see a bit of overhang there, and that's probably due to shear. Very strong 850, 300 millibar shear carrying the tops of those storms further east. So probably some of that going on. And back behind it, you can see the trailing stratiform area and a bit of a bright band up here at about 10,000. So there's probably a lot of lightning back in here and continued rain. So let's take a look at a MCS. Take a look at some slides here. This is your classic single cell storm. This is kind of a conceptual model for that. So you start out with an updraft. This is not going to show up on radar initially. Eventually, the tops of it will start showing some reflectivity up here. And then we start developing precipitation, and that falls to the ground, and we have a downdraft and a outflow pool. During this mature stage, the updraft is still in progress, but the cold pool cuts that off, and then we're left with a large downdraft area, outflow and downdraft, and very little bit of the updraft left. So the MCS kind of defeats this to a certain extent, and this is the structure of a MCS. This is looking to the north here. So you can see the inflow coming in there from the east. This is where we see the Arcus clouds. And we see the big dark wall of precip and hail lightning out to the west as it approaches. And you notice that there's a very strong component of motion towards the back of the storm. So these are actually old convective elements overlying the back of the storm. And here you can see the rear inflow. So this is descending from about the 700 to 500 millibar level. And if you have a lot of dry air, this can really accelerate this rear inflow. And when it reaches the ground, that's where we're talking about those rear inflow notches on those derechos. So, and then down below, this is where you're going to have a lot of scud cloud. And there's usually a lot of spectacular cloud-to-cloud, cloud-to-air lightning up in this area. Usually it's obscured by the scud cloud, but where we do get breaks, you'll get a spectacular view of that. Unfortunately, it's pretty rare to get that scud to break out. This is an older conceptual model of an MCS. We're kind of looking the other way from the north to the south. So the inflow is like this, and you can kind of see how the top of the storm is made up of these old convective elements. And they kind of like push to the back of the storm like that. And then the newer towers are out to the front. And down beneath that, we have a lot of snow falling, a lot of virga, a lot of evaporation, and then especially when you bring in that rear inflow jet, that enhances the evaporation, that intensifies the downdraft and intensifies the rear inflow. And we end up with very strong downburst winds at the surface. And way down here you can kind of see where the scud clouds would be. The other thing that it shows here is theta E, and we haven't talked about that too much, but theta E, your higher values are going to correspond to where your updrafts are. The environment usually has a relatively lower theta E. So you can see that the 340s in this little conceptual model, 340s are looking kind of like this. And that kind of traces the path of the updraft. So there's a 345 right there, and you can kind of see how the updraft spreads up and up like that. And then the lower, cooler, denser air, 332 there, that's what's heading down towards the surface, and you can see how that kind of nips at the heels of the updraft there. This is a diagram that just shows the scales of MCSs, and it shows the relation of time to the size. And it kind of follows a curve kind of like this. So basically, the larger the MCS, the longer lived it is, and lifespans on the order of 8 to 16 hours, pretty common. But usually when you're up in those levels, you're looking at larger structure systems, many hundreds of miles. There's a look at an MCS there over Oklahoma, and you can see the trailing stratiform area. And where we look for the rear inflow notches, that's going to be back in here, right behind the higher intensities. So that's what you're going to look for. And we are in MCS and derecho season for sure. This is an MCS over Africa moving westward with the easterly waves. Looks very similar to what we have here in the U.S. So there's the leading edge of the MCS right there, moving westward. There's the higher reflectivities, and you can also see the trailing stratiform area even back there, and tops up to about 35 to 40,000 feet there. And this is a diagram showing the time affinities for MCS development. So they've went through some case studies. The foreground is when the MCS started. The peak is going to be the middle set, and then the back set is when it died off. So these have a tendency to develop right around peak heating, 23, 24Z. That's going to be about 5, 6 p.m. And then they reach their peak right around here. This is going to be about 4 to 5 UTC. That's going to be about 10 to 11 p.m. And then they die off roughly from about 2, 3 in the morning to about 8 or 9 in the morning. And usually they're gone by noon. So they are strongly nocturnal systems, and it's the peak heating that really triggers them. And you can see very little development in the early afternoon. These are the tracks in May. This is a bunch of case studies here. And you can see a lot of them have a very long track, indicative of the stronger upper level flow. And you can see that they're bunched in Oklahoma, North Texas, a few of them up in Kansas. And then in June, things start shifting north. So we're looking at Missouri, Iowa, Nebraska, Kansas, and then getting into this time of year, Nebraska, Missouri, Iowa, and the Dakotas, especially the Dakotas up there. And this is very important rainfall for the crop yields out there, especially corn. So they're actually beneficial. In July, we see them mostly up north of Kansas. A few of them reach down into southern Kansas. That's pretty rare, but they are mostly a northern plains phenomenon. And then by the end of July, they start shutting down. The upper level flow begins weakening. And just a few stragglers there over Nebraska and Iowa. This is the conceptual model of a bow echo. And you can see how it starts out kind of as a linear system. And as those rear inflow notches get going, as the individual cells intensify, the cold pool generation increases. And we end up with kind of a tendency for this shear, this curling shear on the north side. And that's one area we look for tornado warnings. Also along the leading edge. We've talked about that yesterday. And another way we can look at this is in terms of horizontal vorticity. This is probably getting a little advanced here, but let's take a look at this and just consider the updraft. Okay, so the updraft goes up and the storm starts up. And you can see that if you have like a pencil extending into the chart, so say that's a pencil right there, obviously your pencil is going to turn like that, the way these arrows are showing. And then the other part of the pencil out here is going to rotate the other way. Up at the top, same thing. You have the same kind of curl like that. And then on the other side, we have our pencil kind of rotating like that. But as the cold pool generates and falls and comes down to the ground, well, you see it spreading like that. If we have like a pencil in this area right there, that's going to want to turn this way. And then if we put that just above the cold outflow pool here, this pencil turns this way. And that's kind of synchronized with the updraft right there. And you'll notice that this horizontal vorticity here and this vorticity here, they kind of couple together. And this is what really gets that rear inflow jet coming into the back of the storm. And that augments the cold pool. And especially if you get that dry air coming into the back of the storm, that's what really gets things going. So there's the, I guess that would be a stronger, trying to figure out what the difference between these frames are. Yeah, I think they're just showing the process of what's going on. This shows how the rear inflow jet comes together. So you can see there's some dynamic effects going on in the storm there. Okay, where are we at? Yeah, I think that's the last slide there. So that's about all I got there. So that is our lesson there on MCSs. Don't want to make it too long. And there's one last look at our system there. This was the derecho of June 29th, 2012, and that tracked all the way from Chicago across Indiana, across Ohio, and reached Washington, D.C. later that night. It was a very fast-moving system, and I'm sure some of you out in the Midwest remember this. Okay, taking a look at the chat real quick. Let me see here. Steering currents very unpredictable in the Gulf at this time, according to Ryan. Tropical storm strength at the most by week's end next week. Trade winds will steer it towards Texas, but we'll see. When it gets in the Gulf, all bets are off. What drives the rear inflow jet? Well, that was a question from much earlier, but we've just showed you that. It's a combination of the existing environmental flow along with dry mid-level air. Microburst, that's a downburst, but that's going to be a small-scale downburst. So the definition of a downburst, I think that's a downburst that's only on the scale of a couple of miles at the most. So you wouldn't even be able to resolve this on these distant scans out here. You would be looking for like downburst activity, like on a very tight scale. Let me see if I can... No, I don't see any examples here. Let me bring up that Joplin storm. I think I might be able to show you a little bit of that. Let's see, Joplin, was that May 22nd or was that the tornado day? No, I think that was the tornado. Yeah, let me bring up this July 29th derecho. Let me see if I can... No, there's nothing there. I guess what I'm trying to show you is that when you go down to the velocity, sometimes the signatures, where you have downburst signatures, where you have very strong divergence near the surface, the signatures on those will be very, very small. They'll have very, very small scales, and they're very unmistakable, and they'll have very high intensities across a very small distance. When you measure the distance across that, you'll see only maybe a couple miles at the bottom of the legend on GR2. So you're dealing with a very, very compact, very tight downburst. And so that's when we're talking about microbursts there. But really, it's just kind of a type of downburst. It's not a separate phenomenon. It's just a smaller scale of very strong downbursts. So I wouldn't worry about that too much. But for airplanes, that is a little bit more important when you're talking about small scales, because those can creep up on them. They're associated with much stronger velocity gradients, and that can really be enough where they cannot control the airplane. For us meteorologists, those gradients are not really all that important. We just know that there's very strong winds at the surface. Cool looking storms near Dodge City. Yep, we looked at that. May 22nd, 2011, yeah, that was the F5 tornado for Joplin. Summer pulse thunderstorms, generally the main place I've seen microbursts. The life cycle lends itself to producing microbursts in high Cape days, from Michael O there. Okay, let's head into the forecast here and see what's going to be going on. Storms over Kansas this afternoon. They're going to, looks pretty disorganized, but they'll just kind of continue southeastward overnight into the Ozarks. And looks like a little bit of tail end action here in Oklahoma, Tulsa. So maybe the low-level jet getting started up. This is definitely the place for it. You can see the very strong pressure gradient out here in North Texas. So that's probably helping to feed these storms here in North Oklahoma. So those end up in the Fort Smith area by about 10 in the morning, and you see them die away, just as we would expect from that graph that we saw earlier. The cold front, however, is coming south. There's the synoptic scale cold front, and then the tail end of these storms, outflow. So we got to keep track of where the outflow is, and that could be where we see storms initiate tomorrow, possibly along the Red River tomorrow. And then for the Midwest, we'll take a look at that real quick. Just a couple of clusters of small MCSs. Moving into Indiana, one part right there. Around the middle of the night, another coming through central Illinois from Champaign down to St. Louis. And looks like the best out of that moves through Indiana, about Indianapolis down to maybe just north of Evansville. This is going to be about 5 in the morning, and that'll break up pretty quickly. And we're just left with the synoptic scale cold front coming through. So a little bit of rain there for Illinois, Indiana, Missouri, Kansas, parts of northern Oklahoma, and Arkansas tonight. So let's see what we're looking at for the forecast over the next few days. We're going to move up to the synoptic scale picture. Okay, when we do the webcast tomorrow night, we're going to have the cold front moving south into North Texas. There it is right there, all the way from Blytheville to Texarkana to Dallas, south of Abilene. Look at those strong northeast winds right there, all the way down to Midland. And then it looks like the north part of that's moving through probably Louisville to Columbus, up like that. Very good cold air advection coming in behind that. So we're going to see likely some initiation in northeast Texas. You can see the moisture coming up from the south. Looks like the main axis is around the College Station up to Dallas area. How deep is that moisture? Let's check that out. Let's look at 850 for tomorrow. This is the time where we do the weathercast. Maybe I'll go back 3 hours. Okay. And then back up to 7 p.m. Yeah, you can see that moisture depth is a problem. Not much moisture showing up at 850. See that dry area right there? These are 20s dew points. Let me bring up a sounding for, let's say, Centerville, Texas, Huntsville, Texas. Okay, sounding on its way up. And, well, there is some moisture there, but you can see the 850 millibar level very dry. Now, you remember we've been talking about dry air in the mid-levels. That means that anything that gets organized has the potential to produce downburst winds. So what we need for that is we would need a high Cape day. I don't quite know if we have that. We've got some Cape up here. High Capes plus mid-level dry air, that's usually your best recipe there for strong downburst winds. Got very moist air, but it's a little bit on the shallow side, maybe about 100 millibars deep. That's probably enough to get some showers going for sure. So let's see here. We're looking at, yeah, low 70s dew points. That's some pretty decent moisture. And I'm trying to form a lifted parcel. It looks like we've got capping as a problem. See that right there? 850 millibars showing 23 Celsius. So very warm and very low cap there. So that could keep things pretty well shut down, except maybe along the cold front itself. I'll have to see what the model does for breaking out precip. Okay, back to the forecast. Let's see here for Monday. Upslope for Texas. We have 70s dew points, making it upslope into the Cap Rock area. And then for Tuesday, we come under southerly flow again, and there's our 60s and 70s dew points back up into the Central Plains, closer to the stronger upper level flow. And here comes that tropical system, GFS, going for landfall around the Pensacola area. For Wednesday, very slow landfall on the Florida Panhandle. And you can see the effect that the circulation around that system has on the moisture field. we're looking at only 50, 60 dew points across Texas and Louisiana. So that's not only going to keep precip shut down, but it's going to give us a few mild nights in this area here. New cold front coming south. Very slowly. There it is. Thursday right there. Still got southerly flow, and looks like more storms for Nebraska on Thursday right there. Looks like some good intersection with 70s dew points and the cold front. We've kind of lost our tropical system. And then that cold front just kind of gradually moves southward over the weekend. There's some upslope right there around Amarillo. This is going to be around Sunday. And we're showing some 70s dew points. This is probably the remnants of that old tropical storm over Mississippi, Arkansas, and that low-level moisture. Looks like it just kind of hangs around Louisiana, Alabama, Mississippi, probably going to generate several days worth of showers and thunderstorms in that area, I would think. High pressure pushing that cold front south. So probably a good recipe for some showers along the front there on Monday, the 26th, and then the 27th. Unseasonably cool cold front pushing southward. See that high pressure right there. So very mild air coming southward. And we get a return flow coming up for June 1st and June 2nd. And then for the July 4th weekend, it's looking pretty normal here for Texas and Oklahoma. Just return flow. Looks like probably wet for Iowa and Minnesota, though. Okay, I think that's about all I got for right now. We've done, wow, we went an hour in already. Okay, hopefully that gives you a little good information about MCSs, and also that gives you the forecast there. Hope you all have a good evening, good rest of the weekend, and we will see you tomorrow.